So new project directory, sorry, world file, next. And then part 3, add a rectangle arena, next, finish, save, save. Okay, again, let's add the same epoch. And let's save. Under epoch, let's add a GPS and an inertial unit. I'm going to explain what each one does now. So over here in the turret slot, we're going to add a GPS. And in here also, we're going to add inertial unit. Okay, I don't know if you can see this, but inertial unit, it basically shows you the roll, the pitch, and the yaw. It will give you the angles for these. Actually, let's create a controller as well. So new robot controller, next. Python, next. And then let's call it part 3 controller. And finish. And then under the controller, where is the controller? Here. We select part 3 controller. And then here we paste the code. So we need GPS, inertial unit, and pen as well. Let's add a pen. So ground turrets, pen. Okay, so we added the GPS, inertial unit, pen. Yeah, I think that's it. Now let's make the world a bit bigger. So rectangle arena, floor size, let's make it 2, for example. And then let's make the floor tile size 4 by 4. So as you can see now, the purpose of this code is to go from a position A to position B. Let's say my robot is here, and I'm going to tell it, okay, go back to position 0, 0. So if I save this, and I say in the code, my position is 0, 0. So it's supposed to rotate and then go to 0, 0. Let's see if that will work. Oh, I did not save the code. So it rotated, and then it went to 0, 0. Now it did not go exactly to 0, 0. Why? Because I gave it a radius of 0.3 meters. Because sometimes it might rotate. It might rotate and go like overshoot. So my implementation actually is not the best because I'm basically rotating and then moving. While, for example, some other implementations might basically go like this. Maybe it's faster to go like this. Like this, rotating and then moving might waste time and so on. What if you find an obstacle? You will stop and then rotate again and then go. So that's not a good implementation. But I just did it this way, just to make, like, to show you that you can use GPS and IMU in order to do this type of simulation. So yeah, that was it. I just need to maybe explain the code on how it was working. Again, initialization is the same, the left motor and so on. The GPS, inertial unit, and the pen. Now, why didn't I change these names? Because these are the defaults. So for example, when I added over here the epoch, when I added the children, I added GPS. It already had a name, GPS. So that's why, and even if I go to the motors and all of that stuff, it's going to be mentioned like this. This is basically, I'm setting the goal position. So if I say, okay, let us just view and optional show coordinate system. So I want it to go in the negative X direction and positive Y. So let's say negative 0.5 and in the positive 0.5, for example. So now it's supposed to go to a different location. Yeah, it went to a different location. Again, it's supposed to be somewhere over here, but because we have we can see here that it is within 0.3 meters away from the distance, from the goal. Yeah, that's basically setting the goal position. Here, I'm using the GPS to get the values. So, and the GPS values are going to get us the coordinates, X, Y, and Z. So I'm only interested in the X, Y. I'm not interested in the Z because I'm not going up or down. I'm just going in the X, Y plane. So that's why I picked the 0 and 1. Now get your angle. I want the second one, which is basically this on the Z, because it's rotating on the Z. I want to know what is the angle from, for example, if I'm like this, I want to know, like I'm rotating along the Z axis, and this is my goal. How much, or like what's the angle I need to rotate to reach that position? So this is my IMU. That's why I chose 2. Now the angle to the goal, it's basically like math, where we have the arc tan inverse of the rise over the run. So if you have like a triangle, and let's say this is my goal, and this is where I am. This is the rise, this is the run. So I'm gonna take, I want to find this angle. So I'm gonna take the rise over the run, and it's gonna give me this angle. Okay. Now, how do I know myself Y and myself X? That's from the IMU, right? No, wait, 1 second. That's from the GPS. So I use the GPS to know where is my X and Y, and I have the goal X and Y. I can use this to find the angle. And then I normalize the angle. This is just to make it so that it is between minus 180 and 180 degrees. Or like in radians, it would be pi by 2. Yeah. This is just to normalize it to make it in this range. Oh, sorry, I'm sorry. Pi. Yeah, so from negative pi to pi. Okay. This is just to wait for the GPS. Sometimes in the beginning, the GPS needs some time to set up. So that's why I added some delay here so that I can wait until the GPS is set up. So in this run, I'm waiting for the GPS to be set up, which is just a loop to just do nothing. So here's my angle margin, which is 0.1. And as you can see here, this is like my angle error. So that's basically, I have a margin for the error and a margin for the distance. So if I'm within this distance and within this error, it's good. I'm fine with this. My rotation speed, how fast I want to rotate, and my forward speed also. This you can change the speed of the robot and so on. So the first thing I'm doing is I'm getting the coordinates of X and Y, and I'm getting the yaw angle. Now my angle to the goal, I'll use the X coordinate and the Y coordinate in order to find my angle to the goal. And then based on that angle that I calculated, let's say this angle was 30 degrees. Okay. And my yaw is like, I'm facing this way, yeah? So my yaw will tell me where I'm facing. So let's say it is relative, for example, let's say it's relative to this line. So here it's 90. And this one relative to this line is going to be 120. So what I'm going to do is 120 minus the 90 is going to give me 30. So I know that I need to rotate 30 degrees. So that's how I know my angle error that I need to correct. Now my distance to the goal is the same thing. Do you remember how do you calculate the distance if you have 2 points?
This is the unit point, square Pythagoras.
Yeah, so yeah, exactly. So I want to find this hypotenuse. Actually, there is something called math.hypotenuse. You just pass in the x and the y, and it will give you the distance. So here I'm just printing the x distance and so on. And if my distance is less than the distance margin, I'll just stop and say goal is reached. If my angle error is greater than the angle margin, so let's say I am, for example, my angle error is like 30, and my angle margin is like 5 degrees. So I want to rotate in that case, right? So what I will do is the following. I'll say direction equals minus rotation speed. So if my angle is negative, I want it to go this way. So if I get a positive angle, I don't want to rotate this way. I want it to rotate this way. So I don't have to rotate like the longer way. So this is essentially what is going over here. So if my angle error is greater than the angle margin, then I will do negative rotation speed if my angle error is greater than 0. Otherwise, I'm going to just do the rotation speed. So it basically says either clockwise or counterclockwise. And then I just set the velocity. Why do I do one as positive, one as negative? As I mentioned, if I make one positive, one negative, it's going to rotate. Yeah, and then that's it. Actually, if you want also, just you have 2 minutes. Let's play around with the angle margin. Let's say we want it to be 0.01. Let's see how accurate this is going to be. And 0.01, for example. Let's see if this is going to overshoot or going to actually go. And let's say we want it to be at 0, 0, so we know where 0, 0 is. It's basically right in the middle. And then we bring this back. Okay, in this case, it stopped. But sometimes it might overshoot. So it is, because I'm not giving an angle margin. It is, if you can see, it's going left and right. Why? Because I'm rotating. Maybe if I play with the rotation speed, it's going to fix it. But what's happening is my robot is here. I'm facing this way, but I want to go this way. The correction will make it face this way. Next correction, it will face it this way. So it will never reach this. So that's why we need to add some angle margin. Now, something I forgot to mention, actually. Let me just stop this. And thank you for reminding me. Let me open the other one. Open recent, part 2. Okay, you see the camera, it's updating very frequently, yeah? Now, let's say I make this time step 1000. As you can see, it's very slow. So this time step is basically how frequent or like the refresh rate of your running the thing. So this is something I forgot to mention.